Investigating if antacid tablets will raise the pH of stomach acid.
During this experiment, we tried to find out information about whether antacid tablets would raise the pH of stomach acid. Our hypothesis was that if an antacid has calcium carbonate, it'll raise the pH more. We tested 3 brands, Rolaids, Kirkland, and Pepsid. Ground up the tablets, dissolved them in water, and added to our stomach acid. Both Kirkland and Rolaids raised it to 7 and 6, but Pepsid only raised it to 2. This data does confirm our hypothesis because Kirkland has calcium carbonate and so does Rolaids. The experiment demonstrated how acid-base reactions work, as well as some connections to both healthcare and environmental topics such as acid rain.
These are our materials. We have our hydrochloric acid, our antacid tablets being Kirkland, Pepsid, and Rolaids. We have pH strips to test the pH. We have mortar and pestle. We have our flasks and beakers to help with the hydrochloric acid in our Lemire flasks, and the beakers are for the antacid tablets. And then we have, of course, our safety objects, being our goggles and gloves. We use 90 milliliters of water, and yeah. Our procedure was, well, of course, you put the safety goggles and gloves on for the experiment. And then you take the mass of each antacid tablet and record them. You crush the antacid tablets in separate mortar and pestles. Place each crushed tablet into a separate beaker and add 30 milliliters of water to each, then stir until dissolved. Measure 10 milliliters of hydrochloric acid in all 3 Erlenmeyer flasks using a pipette. Take the initial pH of each flask using pH strips and record that. Add 3 to 4 drops of indicator in the hydrogen chloride solution. Add antacid solution to the hydrogen chloride solution. Stir and mix until completely dissolved. Take the final pH of each solution using pH strips and record. Record any observations about the final solution's color or appearance, and then safely dispose of the final solutions and clean all materials used.
This is our data table containing our brand, our active ingredients, the mass, the initial pH, the final volume, and our observations. This is our graph for the difference between the initial pH and the final pH. This shows the cost effectiveness of each antacid tablets, with Pepsid being the least and Kirkland being the most.
Then here we have our calculations to figure out things such as moles of HCl, moles of H plus final, and different information about different concentrations of atoms. This is our cost effectiveness calculations, showing us cost per tablet, cost per gram, and which one was the most economical, which was Kirkland being the most economical and Pepsid was the least economical. In the experiment, we were attempting to find out how much the pH was affected by different antacid tablet brands. Our hypothesis was that the calcium carbonate would affect the pH more, and that turned out to be true, as both Kirkland and Rolaids had calcium carbonate as the active ingredient, and they both raised the pH considerably more than Pepsid. Through research, we found that the calcium carbonate, when it's introduced, it splits into calcium and a carbate ion. The carbate will bond to free protons, decreasing the concentration of hydrogen ions, which in turn increases the pH. On the other hand, Pepsid, the reason it didn't work out so well was because it reduces the amount of acid your stomach produces, so it likely would help you more in the long term, but it's not as good at reducing it as quickly. In general, antacids work by neutralizing excess stomach acid. They're used for indigestion and relieving heartburn. Common active ingredients besides calcium carbonate are aluminum hydroxide and magnesium carbonate. Throughout this experiment, we learned about different acid and base reactions and how they can be related to concepts such as healthcare and developing new antacid mixes, as well as environmental topics such as acid rain and how we can combat that by introducing limestone, which contains calcium carbonate, to neutralize those affected lakes and soil. Our experiment did have two large flaws, which were that the dyes in the tablets made it hard to see our final indicator solution color, and the tablets did not dissolve all the way in the water, so that might have led to some inaccuracies.